Hey everybody, my name is João Fiadeiro. I'm a product lead at Jump Crypto, and I am going to discuss a couple of things that I've been exploring, mostly in my spare time actually, as someone who has a background in AI/ML and sort of made their way to Web3. I've obviously seen the explosion of language models and was very curious about their application into something that I've been working very close at Jump, which is security research. And so today I'm going to discuss a few ideas, a few things that I've been thinking about on kind of how we can really leverage AI to make Web3 safer. So the problem, projects keep getting wrecked, right? If you go to the wreck leaderboard, it's an amazing website that kind of keeps track of all these instances. You'll see that since late September 2020, there's been about $4.7 billion US dollars in hacks resulting from security vulnerabilities. Now, 21% of those hacks happened on audited protocols. The rest happened on unaudited protocols. This is an issue both for those that have been audited and those who have not been audited. And so we need to find a solution because everyone gets wrecked. It's not just the protocols. More importantly, it's the users and it's the entire industry that loses trust in us. Now, the really big problem here is that audits are slow, laborious, and expensive. And maybe they should be, right? Like, of course, if you're sort of getting a contractor to install a new roof, you don't want it to be the cheapest, fastest thing ever. There's some sort of benefit here of their things being intentional. But the problem is that because it's so slow, you often have a huge lead time. You obviously, have early stage protocols that can't afford $100,000 audits from, top tier security firms. And so sometimes they shrug and they say, okay, well, let's just go to market. And that's definitely not good, right? Because as I said, it puts everyone at risk. And so, the insight here is maybe we can automate certain parts of the process. I don't want to replace security auditors with some complete LLM-based automation, but maybe there are aspects of the workflow that can be significantly improved. For instance, right, you start understanding the target code base, right? You have to have a very deep, thorough analysis of the code, the source code, and really understand the business logic. There's a lot there that we can leverage LLMs for in terms of, code understanding and code summarization, things like that. But then security researchers go on to write unit tests. They conduct static analysis, other formal methods. They use fuzzing, code clone analysis, all sorts of things that really are sort of a hodgepodge of techniques strung together in, some sort of hacky scripts most of the time. And sort of you end up, and obviously the output of all that has to be presented in a nice structured, clean report for your clients with, recommended next steps and mitigation strategies. So there's a lot here that we can actually start breaking down and think about where we can either improve performance in terms of speed or performance in terms of accuracy where powered by LLMs. Now, how do we actually use LLMs? This is actually something that's pretty contentious, right? Just today, I saw a tweet where someone was like, screen capping some project that just proudly said that they use the GPT-4 audit, right? Now, that's not the approach that protocols should take. This is really, really dangerous. And that's actually only going to cause even more mistrust between Web3 practitioners and AI practitioners. Early explorations were actually pretty discouraging. People from top tier firms like Trail of Bits, for example, did a pretty thorough analysis of GPT-4 in the context of security research, and you have a few others, and unfortunately, the results were not great. But my hypothesis here is that there's a lot that has improved both in the models themselves, but also in the techniques that can help us point this research avenue in a much more productive direction. So, for instance, some folks out of Berkeley and Imperial College and UCL just published this, I think, a couple of days ago. Arthur Gervais did a sort of more thorough analysis of how to use LLMs to at least qualify whether a specific smart contract might have an issue, as opposed to what exactly is the issue and how to fix it. And so we're seeing people have a much more robust approach that I'll sort of, I'll go through a couple of interesting methods into sort of understanding how we can, augment the intelligence of those security experts that have really a lot on their plate when they have, back-to-back audits stacked on their to-do list. So models are improving. This isn't a surprise to anyone in this particular call. The context windows in particular are increasing dramatically, right? So once you have these models that have, let's say, up to 100,000 tokens in the context window, you can actually start doing crazy things like just inputting the entire code base. And that actually allows, presumably, some much more insightful analysis from the model in terms of understanding the entire business logic, as opposed to just looking at a specific Solidity contract in isolation. Underlying models are actually trained on much more relevant data. For instance, StarCoder, which was a project by Hugging Face, they took a fairly significant data set from much more recent stuff from GitHub that includes things that are relevant to Web3 engineers, like Move, for instance, right? These new languages, and started coding or actually implementing new models that deal with such data in a much better way. Of course, the ability to fine-tune models on new data is becoming easier and easier by the day. And then something I particularly like is how can you actually use LLMs in the data engineering part, right? How can I actually take all these audits that are out there and they're open by default, but they're in PDFs? How can I use something like LangChain to just scrape a whole bunch of these audits and create some structured data sets that I can then use either for fine-tuning or for like few shot prompt engineering. The techniques are improving too, right? This is, I think, really crucial. This is actually from an upcoming paper from some folks doing a company called Metatrust that I think is very insightful, right? Like they understand that there are limitations both on static code analysis and GPT models. And the combination of both can actually produce a sum greater than the parts. And so the idea here isn't just naively putting in a whole bunch of code and seeing what it spits out, regardless of how sophisticated your prompts are. The idea here is to combine a few different types of inputs and sort of leverage the advantages of both types of I guess outputs from a code basis and from the static analysis that can actually produce more reliable reports with fewer false positives. Of course, there's everything else that people are exploring, right? Like, how can we potentially have some adversarial LLM-based agents, right? Like I have in my particular prototype one sort of prompt that produces a report and another prompt that is aimed at sort of verifying whether the report is actually correct. Fine-tuning models on domain data, this is obviously the most important thing, not just the fine-tuning part, but actually having some eval data sets. This is also really crucial just so we understand our progress against a benchmark. And then the usual fun part of smarter prompt engineering and seeing how far we can get with just that. So since I don't have time, I will sort of follow up, hopefully in whatever forum we have, with a link. But I've sort of been playing around with something I'm calling Robocop, which is a proof of concept, right? The idea is, given some public GitHub repo, pull all the code, pull all the markdown files, make sense of them using Claude to understand the business logic, and basically, iteratively construct some fairly sophisticated prompts that basically allow Claude to, look at a specific Solidity contract and examine it for specific vulnerabilities. Things like reentrancy problems, integer overflows, uninitialized variables, and things like that, right? The thing everyone's talking about, though, is like, how do you actually build a defensible business? The thing that I'm sort of really kind of concerned over the next few weeks as I think about potentially doing a startup out of this idea is really introducing some RLHF here and partnering deeply with security auditors such that we can actually gain a much more insightful understanding of how the output of such models is actually useful or not. And we can actually start aligning security researchers and the models in a more robust way. So obviously, how can this be useful, right? Well, we have to believe that at some point we're going to reach really high accuracy, right? Right now, there's issues with false positives. It's a particularly big issue because these are nuanced things in code, and so if a particular false positive takes away 5 minutes of an engineer's time to verify that it is in fact a problem, that's a huge issue. But let's assume that we work through those. Obviously, this is going to leave time to accelerate the workflow. More crucially, it leaves time to do deeper analysis. And ideally, in the long term, allows protocols to self-serve. Again, I'm not saying this would ever be a replacement to a human audit, but hopefully researchers augmented by these tools can provide something that is much cheaper and much faster than the sort of 6-week lead time and 100 grand it costs. A couple of things I'm interested in exploring. Bugs introduced by incremental code changes. This happens all the time. So how can we actually look at the sort of temporal dimension of repos being contributed to by many, many people? On that topic of different people, something I find very interesting is very frequently security researchers will identify a specific contributor that's maybe a little sloppy, and very often they'll find bugs again and again that are due to code contributed by that particular person. And so often it's an interesting sort of starting point to kind of keep pulling that thread and see how far you can get. And so that's one interesting thing. And of course, I'm really interested in exploring methods like reinforcement learning, right? There's a couple of interesting literature out there around using, different methods to sort of essentially create an agent that's supposed to attack a smart contract, essentially by doing some sort of global fuzzing, seeing how far you can push different variables and see where it breaks. And I think RL could be a really interesting idea to do that at scale and perhaps more robustly. I spoke really fast. I threw a lot at you. You know where to find me. You can Telegram me, Twitter me at JWow, and I'll happily answer and collaborate with any folks who are interested in exploring this further. Thank you so much.
Awesome. Thank you for that, João. So we have about 3 minutes. We can take questions from our viewers. Check and see if we have any written. I'll read them out so that our watchers of the replay know what the question is and don't just hear the answer. If you want to write a question in text form, please place it into the chat tab of the stage. Katie Bush loved to talk.
Thanks, Katie.
Yeah. You can also just share feedback. We love that too. Well, in these last couple of minutes, I'm curious if maybe you could talk a little bit about if and how you would approach prompt engineering differently if you've got, 1,000 tokens on Claude is absolutely crazy by comparison to the other one. So how does something like that affect how we? You mentioned giving every single Solidity contract. That's really, it's hard for me to even imagine how that would change my approach to writing my prompts. So maybe you could talk a little bit about that.
Yeah, for sure. As the context window increases, you can start thinking about adding so many things, because these types of security bugs often arise as not just a combination of the code itself, but the code in the context of whatever virtual machine is running on, right? And so there are ideas of maybe even throwing the entire Ethereum virtual machine into it, and so that it understands really the very complex nuances between the execution environment and the code itself. That's a really interesting thing. If I'm looking at sort of more custom, fine-tuned open source models where I don't have those context windows, I think the interactivity is something really, really crucial. That's the sort of one big insight I'm getting for the security researchers at Jump that I'm talking to. No one necessarily is excited about a single big red button that generates a magical report. The idea is that because this is a very involved process, how can I co-create, right? How can I actually understand with a sort of chat interface what the code is about, understand particular surface areas that are sort of particularly prone to attacks, and that can be done without a crazy context window, right? I'll be doing that at a specific, maybe at a function level. And so I can leverage all the usual techniques of embeddings and whatnot to sort of work with smaller context windows if necessary. But my expectation is, in a year, those context windows will only be bigger. So, in the spirit of skating where the puck's going, maybe let's just focus on that. That's my mindset.
Cool. So maybe if you can get this one in under a minute. I love this question from David. What about using these tools for real-time detection of attacks in live apps?
Yeah, that's super interesting. That's actually an area that if I were to start a business around this, I would definitely complement the auditing piece with the live continuous monitoring. I think obviously there are a couple of providers out there that are looking at continuous alerting for sketchy transactions that are happening, And I think there's potentially some aspect of LLMs that could be leveraged here, because as we all know, if you've ever tried to sign a transaction on MetaMask and you just see a whole bunch of random stuff, like for example, Wormhole, a project that I contributed to, you're doing all these crazy transactions from, one ecosystem and then bridging it and another ecosystem, and you start getting these like really complex things that are really hard to parse. I saw an article a couple of days ago, I can't remember who wrote it, but they had some really interesting insights of like how to use LLMs as universal translation machines, and basically taking these really hard to parse transaction outputs or right, and then sort of putting them in human readable format for that, so that the end user can actually understand those. But maybe it's not necessarily just the end user. Maybe it's some sort of intermediate agent who makes sense of sketchy transactions happening in real time. It's a really interesting idea, David.
Cool. Well, thank you very much, Joao. I'm going to bring on our next speaker now.
Absolutely. It's a pleasure. Thank you.